Here we have AP calculus AB problem. Okay, let's go to the information. A particle is moving along the x-axis according to the position function S of t equals to 3t square into t cube for all t greater than or equal to 0 seconds. So here we have two questions. One is when is the particle moving to the right? Justify. So the second question is when is the particle slowing down? Justify. Okay, now let's answer the first question, that is A, that is we have to find the time interval, so where the particle is moving to the right. So if I want to find the time interval where the particle is moving to the right, I have to find the velocity of the particle. So usually velocity of the particle can be found by finding the derivative of the position function, that is S prime of t. Let me write the stuff over here. Okay, now to get the derivative of the position function, that is S prime of t, we have to find the derivative of this expression with respect to time. So here when I find the derivative of this 3t square, I have to keep the constant 3 as it is. Because when I find the derivative, if there is a constant multiplied by the variable, always I have to keep the constant as it is and I have to find the derivative of the variable alone. So when I find the derivative of this t square with respect to t, I am getting 2t. So I just use the power of derivative. That is, I bring this exponent 2 in front of the variable and subtracted 1 from the exponent. Negative, when I find the derivative of this t cube with respect to t, I am getting 3t square. Again, I use the power rule to get derivative of this t cube. That is, I just brought the exponent 3 in front of the variable and subtracted 1 from the exponent. Okay, now let me do some simplification over here. So 3 times 2t is 60, negative 3t square. Now we can factor this expression. Let me write the stuff. A of t equals to. So what's the greatest common divisor for these two terms? That is 3t. So we can factor 3t out. Now to get the stuff inside the parenthesis, I have to divide these two terms by the one I factor, that is 3t. So when I divide the first term 60 by the one I factor, that is 3t. So this tt will cancel out. This 6 over 3 will become 2. So when I divide this 60 by this 3t, I am getting 2 negative. When I divide this 3t square by this 3t, I am getting just t. Okay, now I got the velocity of the particle and factor from that is 3t times 2 negative t. Okay, now what I have to do is I have to equate the velocity to 0 and find the value of x. Let me do it. So v of t equals to 0. So then we get 3t times 2 negative t equals to 0. So here the product of these two quantities equals to 0. So whenever the product of two terms equals to 0, either the first term equals to 0 or the second term equals to 0, 3t equals to 0 or 2 negative t equals to 0. Okay, now to solve for t in this equation, I have to divide both sides by 3. When I divide both sides by 3, I am getting t equals to 0. So if I solve for 2, if I want to solve for t in this equation, so what I have to do is I have to subtract 2 from both sides. When I do so, this 2 negative will cancel. I'm getting negative t equals to negative 2. So now let me multiply both sides by negative 1 to make this negative t as positive t. So in that case, I'm getting t is equal to 2. So when I equate the velocity to 0, I am getting two values for t. One is t equals to 0, another one is t equals to 2. And the starting value of t is 0 because the question says t has to be greater than or equal to 0. So the least value of t is 0 and the other value we get for t when we equate the velocity to 0. So I am getting 2. So now we have two intervals on the number line. So using the two values of t, 0 and 2. So the first interval is 0 to 2. The second interval is so greater than 2. Okay, now what we have to do is we have to check these two intervals with v of t. For that, we have to take a random value in the first interval that is between 0 and 2. So we can take 1. Now what we have to do is we have to plug in t is equal to 1 into the velocity function, that is v of t. So when I plug in t is equal to 1 into the velocity function, I am getting 3 times 1 because I plug in t is equal to 1. When I plug in t is equal to 1 over here, 2 negative 1 is 1. So here we have 3 positive values and all of them are multiplied. So the product of 3 positive values is always positive. So that is v of t is positive in the first interval, that is between 0 to 2. Okay, now let's take the second interval, that is t is greater than 2 with the velocity function. So the random value we have in this interval is 3. So when I plug in t is equal to 3, 3 times 3 times, when I plug in t equals to 3 over here, 2 negative 3 will become negative 1. So here this first 3 is positive, second 3 is positive, and the third number is negative. So positive times positive is positive, positive times negative is negative. That is in the second interval, that is when t is greater than 2. So the velocity is negative. Okay, now, so here we have to consider the interval where the velocity is positive. Because when the velocity of the particle is positive, then we have to understand the particle is moving to the right. Because according to the first question, we have to find the time. So when the particle is moving to the right, so clearly, so when the time is between 0 to 2 seconds, the velocity is positive. So that is when t is equal to 0, 2. That is when the time interval is 0 to 2 seconds. So the particle is moving to the right. Okay, now we can start answering part B question. Let's go over part B question. That is when is the particle slowing down? So we have to find the time when the particle is slowing down. To find the time when the particle is slowing down, I have to find the acceleration of the particle. So to get the acceleration, what I have to do is I have to find the derivative of the velocity. Okay, now let's quickly find the velocity of the given particle. So that is the derivative of the position function, that is s prime of t. Already we have done this stuff in answering part A question. So now we have to get the derivative of this position function. So the derivative of this 3t square is 60. And the derivative of this t cube is 3t square. So this is actually velocity. So now to get the acceleration, what I have to do is I have to find the derivative of the velocity. So if I find the derivative of this 60, I have to keep the constant 6 as it is. The derivative of t is just 1 negative. Now I have to keep the constant 3 as it is. When I find the derivative of t square, I am getting 2t. So here we have a of t. So a of t equals to 6 times 1 is 6. 3 times 2t is 60. Okay, now let me continue over here. A of t equals to, so let's factor this expression. So the greatest common divisor for these two terms is 6. So we can factor 6 out. When 6 is factored, I'm getting 1 negative t inside the parenthesis. Okay, now what I have to do is I have to equate this acceleration to 0 and solve for t. That is 6 times 1 negative t equals to 0. So now I divide both sides by 6, then 6 will cancel. I'm getting 1 negative t equals to 0. So when I solve for t in this equation, I'm getting t equals to 1. Okay, now let's mark this value on the number line. Already we know that the minimum value of t is 0. Now we got that t is equal to 1. So when we answer part A question, we equated the velocity to 0 and solved for t, and we got two values for t. One is t is equal to 0, already we have marked it, and the other value of t is 2. So that is when t is equal to 0 and t is equal to 2, so the velocity is 0 because we got these two values in part A by equating the velocity to 0. So when t is equal to 0, the velocity is 0. So that means the particle is not moving. And also when t is equal to 2, that is when the time is 2 seconds, also the particle is not moving because when I plug in t is equal to 2, the velocity becomes 0. If the velocity is 0, then the particle is not moving. It's at the same position. So t is equal to 0 as a starting time. So initially the particle is not moving, is at the same position, and when time is equal to 2 seconds, the particle is not moving, it's at the stable position. So only between 0 and 2, the particle is moving, and it's moving to the right. Already we have concluded in part A. So clearly, so this t is equal to 0 as the starting value of t, and this 2 seconds is the ending value of t. So here we get two intervals. The first interval is 0 to 1, and the second interval is 1 to 2. Okay, now what I'm going to do is I'm going to take a random value in the first interval, that is between 0 and 1. So let me take a random value 0.5. So when I plug in this 0.5 for t into the acceleration, so what will happen? So I have to check the sign of the acceleration. So when I plug in t is equal to 0.5, I am getting 6 times 1 negative 0.5 is 0.5. So here we have a product of two positive values. So the product of two positive values is always positive. That is when I take a value, random value in the first interval between 0 and 1, so acceleration is positive. Okay, now let me take a random value in the second interval between 1 to 2 seconds. So let's say that 1.5. When I plug in t is equal to 1.5, what will happen? 6 times 1 negative 1.5 will be negative 0.5. 6 is positive, but this is negative. So when I multiply a positive value and negative value, I am getting a negative value. So between 1 to 2 seconds, the acceleration is negative. So on the left side of t is equal to 1, the acceleration is positive. On the right side of t is equal to 1, the acceleration is negative. If the acceleration is positive, then the velocity is increasing. So that is the particle is moving faster. So from 0 to 1, between 0 to 1 seconds, so the acceleration is positive, that is velocity is increasing, the particle is moving faster. So when you go to the right side of 1, that is in the interval 1 to 2, between 1 second and 2 seconds in this time interval, so the acceleration is negative. Acceleration is negative means the velocity is decreasing. That means the particle is slowing down. That is when t is equal to 1 comma 2, that is in the time interval 1 to 2 seconds, the particle is slowing down.